This conference will now be recorded.
Okay. So in the last class, guys, we took a brief demo on the course called Certified Ethical Hacking. I hope you all got the recording for that. Okay, if not, I'll be dropping the recording for it in the group chat as well. Okay. And today actually starts the first class of the ethical hacking course. We'll be discussing something called networking fundamentals, a very important prerequisite for cybersecurity. Okay, understanding what networking is, what IP addresses are, what are the categories of IP addresses, what are some important protocols in networking, what is DHCP protocol, what is DNS protocol. So we'll be covering all the networking fundamentals required for cybersecurity. Again, as mentioned already, a very important prerequisite. Again, not all institutes include this, guys, but again, it's very important to know what these networking concepts are before you join cybersecurity. Okay. And as a bonus, I've added them in the course itself. Okay. So because in the upcoming sessions, when we work in different cybersecurity modules, we'll be going through logs, we'll be analyzing the traffic, we'll learn we'll look at a lot of IP addresses there. So looking at that IP, you have to figure out where the attack is initiating from. What does that IP signify? Okay, what these TCP packets are, what these UDP packets are. So to understand all that, you would need these networking fundamental concepts. Okay, so let's get started without any further ado. Okay, so when you talk about networking, guys, there are three important definitions to know. What is networking, what are networks, and what are hosts. When you talk about networking, this is the practice of connecting information devices with each other. Okay? So in an organization, you have multiple sorts of devices. You have routers, you have switches, you have firewalls, you have client operating system devices for the employees. You have servers, various categories of servers again, FTP servers, DNS servers, DHCP servers, SNMP servers. Okay. You have mobile phones as well. Okay. So the process of connecting these information devices with each other so that they can share the resources, so that they can share information is called as networking. Okay. Now, when you talk about a network, that is the collection of these interconnected devices. So that collective group of these devices which can communicate with each other is called as a network. Okay. And each individual system or each individual information system or information device in that network is referred to as a host. So a host refers to any device connected to that network that can transmit or receive data. Again, as mentioned, as an example, your computers, your printers, your routers, your firewalls, your servers, your mobile phones, every singular device is called as a host. Okay. Now, just like how we humans have our names to address each other or to identify each other, these devices also have names in a similar format. And these names are called as IP addresses, Internet Protocol addresses. Okay. To define an IP address, each host on a network has a unique identifier. Okay. And this unique identifier, known as an IP address, allows for communication to occur between these hosts. So to address each other, to identify one system from the other one, you have the IP addresses, a unique IP address assigned to each device. Okay. And there's important properties for this IP address. What we're going to learn about in this course is IPv4 addresses again, specifically, guys. So these IP addresses were developed by the US military in the late 1950s or so. There were multiple experimental versions again, IP version 1, IP version 2, IP version 3. What successfully worked out was IP version 4, Internet Protocol version 4. And we're still using IPv4 addresses even in today's world. So what we're going to discuss is about IPv4 addresses. Okay. And again, as mentioned, these IPv4 addresses have a few important properties of it to remember. Okay. So let's get into that. Firstly, your IPv4 address is a 32-bit address. What I mean by 32-bit address is that it contains 32 zeros or ones consecutively. Okay. So the entire address is a series of multiple zeros and ones. Okay. And if you count each of them, there'll be a total of 32 in them. Okay. And this entire 32-bit address again is divided four equal parts, okay, where each portion has 8 bits in it, and each of that 8-bit portion is known as an octet. And each octet again is separated by a dot symbol. Okay. So as mentioned, this is what your typical IPv4 address would look like. There are 32 zeros and ones here. Each of these zeros or ones is called as a bit. That's that smallest data value a computer can store. Okay, it can either be equal to the value of 0 or equal to the value of 1. Okay. And this entire 32-bit address is divided in 4 equal parts again. Each part consists of 8 bits in it, and it's called as an octet. And each octet again is separated by a dot sum, if you notice. So there are 8 bits here, then a dot, then another 8 bits, then a dot, then another 8 bits, then a dot, and then another 8 bits. So this represents your entire 32-bit IPv4 address. So what you see here is the language of zeros and ones, which is also commonly known as the binary language. Okay, computers communicate with each other at the core level in binary addresses itself, okay? Or the language of zeros and ones itself. Okay, but we humans don't understand binary so well. What we regularly use or what we regularly again work with are decimal numbers, numbers from 0 to 9. So now I'm going to show you how do you convert any computer readable binary address into a human readable decimal address. So this number 11000000 is actually equal to 190. This number 10101000 is actually equal to 168. This number with all zeros is actually equal to 0 itself. And this number 00001010 is equal to 10. So we'll learn now how do you convert any binary number to a human readable decimal number. And this conversion will allow us to learn a lot more in depth about IP addresses as well. Okay. So before we progress any further, any questions or doubts up to this point, guys? Anyone? Siddharth, Ashok, Suvendu, Tapas, Ravi, Saipriya, Revati. Hello. Okay, Ravi. Others? Saipriya, any questions? Revati, any questions?
No, sir.
Okay, Ashok has no questions. Siddharth also mentioned no questions. Yeah, Revati, your mic is unmuted. Any questions? I can't hear you. Okay, perfect. Saipriya, I hope you can hear me as well. Any questions? Yeah.
No.
There's some issue with Saipriya's mic. But anyways, coming back to this. So as mentioned, let's talk about the conversion now. Now, there's a very simple procedure to convert any binary number to a human readable decimal number, guys. Let's take the example of this number now. 10101010. So I have an octet here, 8 bits. To convert this 8-bit octet into a human readable decimal number, rule number 1, as you write down, again, values of 2 power 0 all the way up to 2 power 7 from right to left. So under the rightmost bit, we have 2 power 0, then you have 2 power 1, then 2 power 2, then 2 power 3, then 2 power 4, then 2 power 5, then 2 power 6, and then 2 power 7. So from right to left, under each bit, you're writing down these values. Once these values are written down, then you multiply the lower value with the top bit and keep on adding it till the end. So 2 power 0 into 0 plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 plus 2 power 4 into 0 plus 2 power 5 into 1 plus 2 power 6 into 0 plus 2 power 7 into 1. So no matter what the bit be on the top, whatever the binary number be on the top, you just multiply these values on the bottom to the top bit and keep on adding it till the end number. Okay. And if you have a question why specifically 2 power everywhere, it's a binary number. There are only 2 possibilities, hence 2 power everything. Okay. Now let's write down the values for these numbers from 2 power 0 to 2 power 7 so that you can substitute here and start calculating. So anything to the power 0 is always equal to 1. It's a mathematical rule. So therefore 2 power 0 is also equal to 1. 2 power 1 is 2 itself. 2 power 2 is 0. Sorry, my bad. 2 power 2 is 4. My bad. 2 power 0 is 1. 2 power 1 is 2. 2 power 2 is 4. 2 power 3 is 2 into 2 into 2. 3 times. That's 8. 2 power 4 is 16. 2 power 5 is 32. 2 power 6 is 64. And 2 power 7 is 128. Now that you have these values here, you can substitute them here and start calculating. So 2 power 0 into 0. 2 power 0 is 1. So 1 into 0 is simply 0. 2 power 1 into 1. 2 power 1 is 2. So 2 into 1, that's 2. 2 power 2 into 0, 0 again. 2 power 3 into 1, that's 8. 2 power 4 into 0, 0 again. 2 power 5 into 1, that's 32. 2 power 6 into 0, 0 again. 2 power 7 into 1, 128. Okay. Now, since we have these values, we can just add them up. 128 plus 32 over that's 160. 160 plus 8, 168. 168 plus 2, 170. So when we read the number 10101010 in the decimal format, it's 170. We humans understand it as 170. The computer reads it as 10101010. Something like high frequency, low frequency, high frequency, low frequency, high, low, high, low. When that exact sequence of frequencies flows through a computer, it understands it as the number 170. Okay. So the reason I'm explaining you all these binary to decimal numbers is to understand the range of IP addresses, guys. Okay. So I'll come to that in a bit. But any questions or doubts up to this procedure, guys? Anyone? Ashok, Siddharth, Suvendu, Ravi, uh, Revati, Saipia. Okay, assuming no questions. If this procedure is clear, I have two other numbers here, guys. 01010101 and all ones. So if you have a pen and a paper beside you, what I want you to do is calculate the decimal values for these binary numbers and give me the answers for that. Okay. So there's the first example 01010101 and then all ones. Take your time, no rush. If you have a pen and a paper beside you, please calculate and give me the answers. I've written down the values for all the numbers from 2 power 0 to 2 power 7 on the screen here.
First one, example one would be 85.
85. Okay. So I've got a lot of answers as 85. Let's check that out. So 2 power 0 into 1, that's 1. 2 power 1 into 0, 0. 2 power 2 into 1, that's 4. 2 power 3 into 0, 0. 2 power 4 into 1, that's 16. 2 power 5 into 0, 0. 2 power 6 into 1, 64. And 2 power 7 into 0, 0. Okay. And if you add all this up, 64 plus 16, that's 80. 80 plus 4, 84. 84 plus 1, 85. Correct answer. Okay. Yeah. Let's go for the next one now.
And second answer would be 255.
Okay, I've got one answer. Let's wait for the other answers as well, guys. When you have all ones here, you'll have to add all the numbers. Any answers for the next one, Ravi or Revati or Cycle? 255. Okay, let's check that out. So when you have all ones, you would add all the numbers. So 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And that would give you 255. Absolutely correct answers, guys. Great job. Okay. Now, the reason as mentioned, I'm explaining all this is to understand the range of IP addresses. So if I had to get the first IP, what do I do for that? All I have to do is just put zeros everywhere. In the first octet, all zeros. In the second octet, all zeros. In the third octet, all zeros. And the last octet as well, all zeros. And when I put all zeros everywhere, the first IP address in decimal numbers is simply 0.0.0.0. Okay. And if I had to get the last IP, what would the other alternative be, guys? Putting the maximum number, which is all ones. And when I put all ones, we get 255.255.255.255. So no matter what IP address you take in the entire IPv4 range, they would always exist between the numbers 0 and 255. They cannot go beyond 255. Okay, because logically, when you put an octet with all ones, the maximum it can go up to is 255 itself. Okay, not more than that. So you will never have an IP with numbers above 255 again. Okay. And if you have to calculate how many IPs are there in total, guys, each number here has two possibilities, or each bit here has two possibilities. And there are a total of 32 bits in total. So two possibilities into 2, into 2, into 2, into 2, into 2, 2, 2, 2, like that. You have 32 bits. So to get the total number of IPs, you would get with a simple formula 2 raised to the power of 32. And that would be 4.3 billion IP addresses approximately. So back then when these IP addresses were invented in the 1950s or so, again, oh, sorry, as mentioned, there were not many information systems back then. There were no phones as well. Okay, so they thought 4.3 billion IP is a very large number, sufficient for the rest of eternity. But again, the population itself is 8 billion people or 9 billion people today, I suppose. And each person again has multiple devices. So if you just assign each individual IP to each system, these 4.3 billion IPs would never have sufficed. Okay. So that's why these IPs are categorized again. There are multiple different types of categories in it. There's something called as classes, then there's something called as public and private IPs. We'll discuss all that. Okay. But before we dive into the categories, let's talk about the sequencing of IPs. Now we know this is the first IP. We know this is the last IP. What about the sequence of IPs in between? How do the IPs progress one after the other? Okay. So to understand the sequence, again, there are two simple rules, guys. Okay. Let me explain the sequence in a simple notepad file. So we know the first IP is 0000. I've written down that IP over here. Okay. To progress into the next IP, there's rule number 1. You always start incrementing from the rightmost octet. Okay. So the value of the rightmost octet always increases by 1. Oh, sorry. Where did I go? Yes. So again, if we have the first IP as 0000, the next IP would be 0001. So the rightmost octet is increasing by a value of 1. Okay. After 0001, you have 0002, then 03, then 04, then 05, then 06. Goes all the way up to the number 000255. Okay. Now after 000255, do not make the mistake of adding the next IP as 000256. Please note, we do not have IPs above the number 255. So this is an invalid IP. Okay. So once you reach the maximum number 255, then comes rule number 2, which is once the rightmost octet reaches the maximum value, then you move to the left octet. As simple as that. So that 255 cycles back to 0 again. Okay. And the left octet, the one just next to it, increases by 1. So after 0255, you have 10. Okay. Now after 10, don't directly jump to 0020. That would be wrong again. Remember rule number 1, always increment from the rightmost octet. So this rightmost octet increases by 1 again. So after 10, you have 11, 12, 13, 14, which goes up to 1255. Okay. And then you have 20. So this 255 cycles back to 0. And this 1 changes to 2. Okay. So if you notice, there's a pattern forming here. 00, to 0255, 10 to 1255, 20 to 2255, 30 to 3255, 40 to 4255, 50 to 5255. Like that, the pattern keeps on repeating. And down the line, you would have somewhere 2540 to 254255. And finally, 2550, which goes up to 255255. Now, both these octets are filled. What happens next? Same logic. All the 255s cycle back to zeros. And the next zero, the next left octet increments by 1. Okay. After that, if you notice, you have the same first pattern again, 00. Okay. So that 00 now again goes to 0255. Again, 10 goes to 1255. 20 goes to 2255. So that exact pattern again is repeating over here. So whatever repeated from 000 all the way up to 0255, 255, same thing repeats again from 100 to 1255, 255. Then 200 to 2255, 255. 300 to 3255, 255. 400 to 4255, 255. 500 to 5255, 255. Like that, the pattern keeps on repeating and repeating and repeating. And down the line, you would have 25500 to 255, 255, 255. All these three octets are full now. What happens next? They cycle back to zeros, and the next octet increments by 1. Okay. So the 0 now changes to 1 finally. Okay. And whatever entire cycle repeated from the first IP 0000 to 0255, 255, 255, same cycle again repeats from 1000 to 1255, 255, 255. Okay. So exact same pattern which I had over here from the first IP up to here 0255, 255, 255. Same thing repeats from 1000 to 1255, 255, 255. Again from 2000 to 2255, 255, 255. From 3000 to 3255, 255, 255. And finally, somewhere down the line, you would have 255000 to 255, 255, 255, 255. Here's the first IP, and here's the last IP. Okay. And if you count each and every single IP one after the other, you would have a total of 4.3 billion IP addresses approximately. Definitely, we did skip a lot of them in between, but yeah, if you count each and every single IP, if you write down each and every single IP, there would be a total of 4.3 billion IP addresses this way. Okay, that's the entire sequence of IPs, guys. Again, this is important in a while. I'll explain why, but yeah, I hope you have understood the sequence, guys. Any questions or doubts up to this point? Anyone? Ravi, Revati, Saifia, Ashok, Siddharth, Suvendu, Tapas. Yeah, Ravi, you were saying something. All good. Okay. Right. Revati, any questions? Saipia, any questions? Ashok, any questions? Siddharth, any questions? Suvendu, Tapas, any questions?
No questions, sir.
Right. No questions. Perfect. Let's move on now. Let's talk about the classification. So we all know these are all the IPs and the total of 4.3 billion IPs. Now these entire 4.3 billion IPs as mentioned are categorized. So firstly, there are 5 important categories called classes. So there's class A, class B, class C, class D, and class C. So these rectangular boxes are the first 5 categories. So this entire white rectangle is the entire 4.3 billion IPs, let's say. That entire 4.3 billion IPs is divided in 5 classes first. Class A, B, C, D, and E. Okay. And then again, each class is subcategorized in 2 parts. So in class A, there's public IPs and then private IPs. Similarly, in class B and class C also, there are public IPs and private IPs respectively. Okay. But class D and class C are exceptions. Unlike class A, B, and C, they don't have private IPs in them. Okay. They only have public IPs. Okay. So there are no private IPs in class D and class C. There are only public IPs in them. Okay. So let's talk about what public and private IPs are first, and then we'll talk about the classes in the upcoming sessions. Okay. So what are public and private IPs? To understand this, let's take the example of our home network itself. So in our home, we have a Wi-Fi router, right? And to that Wi-Fi router, we have all our other devices connected to it. So you could have your laptop, your smartphones, your smartwatches, your smart TVs, your iPads, whatnot. You have multiple devices at your home. All of these devices are connected to one singular Wi-Fi router, right? Now, all of these devices, guys, are your local private network devices. Your local networks or private networks are also commonly known as intranets. Okay. So intranet is a local network which consists of only devices belonging to one single local network. Okay. So this is your home network. And in that home network, you have these multiple devices communicating with each other. So for that communication, you need something called private IPs. So private IPs are the addresses which are assigned in a local network or an intranet network. Okay. And each of these private IPs is unique to every device here. And they're capable, again, these private IPs allow these devices to communicate with each other. Okay. And private IPs are completely in your control. You can assign whatever private IP you want to your devices. It's in your hands. Okay. So when you define private IPs, these are the addresses used within private networks, such as home networks, offices, or organizations for local communication. Again, please note, private IPs cannot directly access the public internet. Okay. With just private IPs, you don't have internet connectivity. You cannot communicate with any website on the internet. Okay. They are only used for your local communication. They only allow devices within the same local network to communicate with each other. Okay. So if your phone wants to communicate with your laptop, or if your laptop wants to communicate with the router, or if your router wants to communicate with the TV. So for this local communication only, you have the private IPs. Okay. So if I have an organization, and in that organization, if I have 100 systems, and if I want all of these 100 systems to communicate with each other, I do not need internet access for that. I can just assign a unique private IP to each system, and they can start communicating and transmitting data and sharing files with each other. Okay. So private IPs are the addresses used in a local network only for local network communication. Okay. And just in case, if you want to figure out what your private IP is, if you're owning a Windows system, in your Windows device, you can search or open command prompt, CMD. And in the command prompt, you can run a command called ipconfig. It stands for Internet Protocol Configuration. Okay. Now, when I hit enter, since I'm connected on my Wi-Fi network, this is the private IP address that my laptop is getting right now, 192.168.0.5. Now, why specifically 192.168? I'll come to this later. Don't worry. Okay, but this is the IP of my laptop. And default gateway is nothing but my Wi-Fi router. So the router is getting 0.1. So each device in the network has a unique IP. Okay. My router is 1 and my laptop is 5. Again, they can communicate or identify each other with those addresses. Okay. Now, excuse me. Now, when any of these devices wants to communicate with the internet, with the devices on the internet, when you want to visit any website, when you want to join this meeting or whatever it is, for that, you need a public IP. So your router, Wi-Fi router, gets a cable attached to it. Okay, from outside your house, there's a cable coming and attaching to your router. Okay, it could be an optical fiber cable, an RJ45 cable, whatever it be. You would have a LAN cable or an optical fiber cable coming and joining to your router. So that cable is coming from the ISP, Internet Service Provider. So there might be a hub somewhere close to your house. Again, from that hub, there's a cable coming and accessing your router. Okay. That cable is provided by the internet service provider, and that cable carries public IPs. Okay. So ISPs are the organizations which give you the connection to the internet. Okay. In India, we have ISPs like Airtel, Hibernate, Geo, Reliance Geo, etc., etc. In US, you might have ISPs like AT&T, T-Mobile, Verizon. All of these are ISPs in US. Okay. So all these ISPs, internet service providers, give you the connection of the internet with the help of public IPs. Okay. So that cable that runs into your house and attaches to the router is what carries the public IP. And when any of these devices wants to communicate with the internet, they would use that public IP. They would share that public IP among themselves to access the internet. So if my phone wants to communicate with google.com, first it sends a packet from its private IP to the router's private IP. Now, a router is a device which is capable of transmitting data across networks. So from its local private network, it can shift the packet to the public network, the internet. Okay. So it can shift the packet from the private IP to the public IP. Okay. And with that public IP, it reaches the ISP, the hub closest to you. And from there, it travels across the internet, across multiple different servers. And then eventually it will reach google.com. Okay. So for local communication, you have private IPs. For internet communication, you have public IPs. Okay, that's the important difference to note. So to define public IPs, these are the addresses, globally unique IP addresses, which are used to identify individual devices on the internet. Okay, they're allocated by the internet service provider, ISP, and they're routable over the internet. And if you want to check what your IP address is, your public IP addresses, you can open up your browser, and in your browser, you can search what is my IP. With that one single search, you get to know what your public IP is. So this is my current public IP. If I want more details on this, I can click this link here. What is my IP address.com? And this provides me my ISP information as well. So right now my ISP is Act 5 Minute, which is also commonly known as Beam Telecom. And this is the public IP provided to me in my region. So I'm in Visakhapatnam here in Andhra Pradesh, India. Okay, and this is the public IP that my systems are using to access internet. Okay, is that clear, guys? Any questions or doubts regarding what public IPs are or private IPs are? Anyone? Ashok, Siddharth, Suvendu, Tapas, Ravi, Revati, Cypriya. Any questions, guys?
No, we are good.
Others? Okay, Suvendu, no questions. Ashok, any questions? Siddharth, any questions? Tapas, any questions? Ravi, any questions? Revati, any questions? Cypriya. Oh, okay. Yeah, Revati.
Yeah.
Okay. Cypriya, is your mic still not working or so? Any issues with the mic? I am unable to hear you. I hope you can hear me. Okay. Anyways, moving on. So as mentioned, that would be your entire scenario of public and private IPs and where you're using which type of or which category of IPs there. Okay. Now let's talk about the classes, guys. So as mentioned, there are 5 important classes. We'll talk about the relevance of classes in the next session. Today, we'll talk about the range of each class. Okay, we'll be concluding our session here after we discuss the range of each class here. Okay. So as mentioned, there are 5 classes, class A, B, C, D, and E. Okay. And each of these classes has a unique range, guys. So your entire IPv4 range from 0000 to 255, 255, 255, 255 is divided in 5 classes. Okay. And each class has its own unique range. And it's very, very, very important to remember these ranges. Okay. Do not worry. There's a simple technique to remember it. Okay. Nothing too complex. Okay. Might seem very complex right now, but don't worry. It's there's an easy method to do so. Okay. So firstly, when you talk about class A, that starts at the first IP, 0000. And class E obviously ends at the last IP, 255, 255, 255, 255. So that's the starting range for class A, the ending range for class E. We know those IPs already. Okay. Now class A starts at 0, and this goes all the way up to 127, 255, 255, 255. Okay. So if you notice, the last 3 octets are 255s, and the leftmost octet is 127. Now, according to the sequence of IPs, what should the next IP be, guys? All the 255s cycle back to zeros, and the 127 increments by 1. So class B starts at 128,000 according to the sequence, right? So class B starts at 128,000, and this goes all the way up to 191, 255, 255, 255. Since it's ending at 191, class C starts at 192,000. Okay. From 192,000, it goes up to 223, 255, 255, 255. Okay. Since it's ending at 223, class D starts at 224. Okay. From 224,000, it goes all the way up to 239, 255, 255, 255. Since it's ending at 239, class E starts at 240. Okay. And from 240,000, it goes up to 255, 255, 255, 255. Okay. So the only four numbers you have to remember are these numbers: 127, 191, 223, and 239. Because from these four numbers, you automatically get the range for the next class. Class A 0 to 127, class B 128 to 191, class C 192 to 223, class D 224 to 239, and class E 240 to 255. Okay. On the left side, you have all even numbers. On the right side, you have all odd numbers. Okay. On the left side, you have all zeros in the last three ending octets. On the right side, you have all 255s on the last three ending octets. Okay. So the only four numbers you have to remember are 127, 191, 223, and 239. It's like a phone number. Okay. A slightly complex phone number, but you have to remember these four numbers. Okay. Now, again, in each class, guys, there's a set of public IPs and a set of private IPs. Okay. So in class A, between 0000 and 127.255.255.255, there's a small private IP set from 10.000 to 10.255.255.255. So any IP within this range is a private IP, and any IP outside that range is a public IP by default. So any IP within this range can be used in your local network, and any IP outside that range belongs to the ISP for internet access. Okay, that's what you have to remember. Okay, in class B as well, similarly, between 128 and 191, there's a small range: 172.16.00 to 172.31.255.255. Any IP within this range is a private IP. Any IP outside that range is a public IP. Similarly, in class C as well, between 192 and 223, there's a small range: 192.168.00 to 192.168.255.255. Any IP within this is a private IP. Any IP outside this range is a public IP. And in class D and class E, if you remember, they're only public IPs. There are no private IPs in class D and class E. So no private IPs. To elaborate on this a bit more further, we can take the example of class A. So class A starts at the first IP 0000, and it goes up to the last IP 127, 255, 255, 255. That's the entire range. Now in that entire class A range, there's a small private IP range from 10.000 to 10.255.255.255. Okay, that's the small private IP range in class A. Any IP within that range is something you can use in your local home networks or organization or wherever. Okay. So in private intranet networks, you can use these private IPs. Okay. And any IP outside this range, which means from 0 up to 10, which is 9.255.255.255, and after 10, from 11 to 127, there are two sets of public IPs. So in a similar fashion, in every class, you have one small private IP set and two sets of public IPs, one on each side. Okay. Is that clear? Any questions? Anyone?
Hi, student is here this side.
Yeah, so
So the public IP and ISP both are same, as you have seen.
yes, again, if you talk about public IPs, those are the IPs allocated to the ISPs itself to access the internet. Same thing. So there are some public IPs which are special. Again, I'll talk about that. So class D and class E public IPs are not with ISP. They serve a different purpose. But in class A, B, and C, all the public IPs we refer to, they're the same IPs as with the ISP itself. Okay. Class B and class C are quite exceptional. So those IPs do not belong to ISP. They are reserved for special organizations. I'll talk about that in the next session. Okay. But for now, whenever you talk about public IPs in class A, B, or C, they're the same IPs belonging to the ISP for internet access. Okay. Right. Any other questions, guys? Okay, assuming no questions, let's do a small exercise now, a fun little exercise to understand or to, again, figure out which IP belongs to which category. Okay, so what I'm going to do now is I'm going to write down some random IPs, and looking at this table here, you have to tell me which IP belongs to which class and whether they're public or private IPs. Okay, so let me quickly write down some IPs first. Okay, so let's see. Hmm. Okay. Okay. So I've written down some random IPs here, guys. What I want you to do is look at these ranges here and now tell me which IP belongs to which class and whether they are public or private IPs. Let me give you the answers for the first two ones, and then you can proceed and give me the answers for the rest. Okay. So looking at the first IP here, 10.20.30.40. If you look at the first octet, it says 10. Now, where does 10 fall under? It falls between 0 and 127. So always look at the first octet to figure out which class it belongs to. So 10 falls between 0 and 127. So therefore, this is a class A IP. Now, once you know that this is class A, you would focus your attention on this specific range. For an IP to be a private IP in class A, first octet should be 10. Remaining octets can be anything from 0 to 255. So here I have the first octet as 10. And the other octets anything from 0 to 255. That's falling in that range. So therefore, this is a private IP. Okay. Similarly, for an IP to be a private IP in class B, what's the condition? First octet should be 172. Second octet should be between 16 and 31. And the remaining two octets can be anything from 0 to 255s. Okay. For class C, first octet should be 192. Second octet should be 168. The remaining two octets can be anything from 0 to 255. So if it is falling in that category, they are private IPs. If they're outside that range, they are public IPs. Looking at the next IP, 192, 169, 010. 192 falls in class C here. Okay, so this is a class C IP. Now, once we know this is class C, we'll focus our attention here. Okay. First octet is 192. That seems to match. Second octet is 169. Okay. But for it to be a private IP, it should be 168. So since it's not falling under 168 and it's outside that range, so therefore this is a public IP. Okay. So I hope you've understood why that is a public IP. Okay. So yeah. Okay. Moving on. Next one. 172, 35, 45, 55. Which class is this, guys? I think I've got one answer in the chat box already.
Class B.
Yes, this is a class B address.
Class B
Public.
for private.
Oh, I've got one answer as public and one answer as private. Which one is correct?
Public.
Yes, this is a public IP. Why is this a public IP? First octet is 172. That seems to match. But the second octet is not between 16 and 31. It's 35, which is outside the range. So
Yeah.
therefore, that's a public IP. Okay. Next one. Oh, 1 second. It's not visible. Yeah, much better. Just a second, guys. Give me 1 minute. Yeah, much better. Right. So next IP, 92, 10, 25, 54. Which class is this? Class A, correct answer. And public or private? Public IP. Perfect. Okay, I think that's Ravi answered. Yeah, correct answer, Ravi. Okay. Moving on, next one, guys. 192, 168, 0.5.
Class C. Private.
Class C and private. Correct answer. Next one, 172, 20, 30, 40.
Class B. Private.
Class B private.
Correct answer. So sorry. It's glitching a bit. Yeah, but this is class B and this is a private IP. Next one, 225, 240, 10, 10.
Class D.
Class B and
Public IP.
correct answer. Next one.
Again, class E for public IP.
Oh, sorry. I think you're going for the next
Sorry.
IP, guys. It's
Okay.
this one. 142, 250, 10, 20.
Class
Class
C.
B. Oh, I've got one answer as class B and one answer as class C. Which class
Class
is this? Class B, correct. For Bombay. Right. Class B,
Class B. Public.
Public
public.
IP. Correct.
Correct answer. Next one.
Class E.
Class E, correct.
Public.
Public or private?
Public.
Public. No, private IPs in Class E, correct. Next one. 10.180.9.26.
Class A private.
Correct.
Class A private.
This is Class A, and this is a private. Good answer. Next one. 200.100.200.100. Class C.
Class C
Class C.
private.
Private.
Public.
Sorry, public.
Yeah. Public. Okay. Next one. 11.15.16.17.
This is
Class
class
A.
A.
Correct. I've got one answer as private and one answer as public. Right. This is public IP. Correct answer. Next one. 49, 250, 192, 221. Class A and public. Okay.
Public.
Now, if you remember, I've shown you two IP addresses earlier. If I went to my browser, I got an address here, 49, 204, 238, 162. If I copy this and if I paste it back here, can you tell me which class is this and whether it's public or private? 49, 204, 238, 162.
Class A public.
And this is public IP, correct answer. And if you notice, what we checked over here in the browser was for public IP itself, the IP which was giving me my internet access. Okay. And the other one, if I went to my command prompt, CMD, and if I run a command ipconfig, what does this show us? 192.168.0.5. If I copy that, paste it in the notepad file, and go back to our notes, can you tell me which IP is this?
This is
192.168.
Class
Class
B.
C.
Class C public.
Private, right? Because in our command prompt, we see the private IP. On the internet, when you search for what is my IP, that shows the public IP. So now I hope you understood why am I getting 192.168 something here, and why am I getting 49.204 something here? Okay. So again, this IP is completely in the ISP's control, guys. We cannot assign this IP ourselves. They can give us any random IP from the public IP range. But this IP 192.168 something, this is in our control. If I want, I can change this as well. Okay. In the next session, I'm going to show you how to do that. Okay. How do you assign your private IP is what we're going to talk about in the next session. And before that, we'll also discuss the relevance of these 5 classes. A very commonly asked question among students is, why do we have 5 separate classes? Why not just one single class with some public and private IPs in it? It would have made our job a lot easier, right? But no, there's a reason for it. There's a reason, or again, a necessity for 5 classes. Okay. So each class has its own unique properties. We'll talk about the relevance of each of these classes in the next session. What is class A? What is class B? What is class C? Why do we need these 5 separate classes? Okay. What is subnet mask? Okay. So if you check your command prompt, you see a value here called subnet mask. Okay. So what does this subnet mask specify? Okay. We'll talk about that. We'll talk about how do you assign a private IP? How can you assign it manually? How do you get it automatically from a DHCP server? What is the DHCP protocol? What is the DNS protocol? Why do we need DNS servers? Okay, what are special IPs? We'll talk about all these concepts in the next class. Okay, so tomorrow we'll be concluding all the networking fundamentals. Again, very, very important, no matter what domain you're working in the IT field, guys. So no matter what domain you work on, you will always keep coming across IP addresses. Unless, again, even in programming as well, sometimes you might have to assign IPs if you're working with networking protocols and all in programming. But yeah, in IT domain, you will always have an issue somewhere in the network where you'll have to troubleshoot. So all of these concepts are necessary there. Okay. And in cybersecurity, they are even more important. Okay. So that's why we are covering all this. Okay. In tomorrow's class, we will be concluding the networking fundamentals. And then after that, we'll talk about the practical aspect. Okay. How do you install the lab simulation for the entire course? Okay. How do you install the operating system called Kali, okay, which is a penetration testing operating system. We'll talk about all that in the next session after that. Okay. So yeah, this is a brief intro on how my classes would be. Okay. If you're interested, please enroll at the earliest with your organizations, with your respective institutes. Okay. And please do join the session tomorrow on the same link, guys. We'll be connecting back and we'll be concluding the networking fundamentals part. Okay. Thank you for joining the session today.
Sir, can you wait for a moment?
Sorry, yeah, Tapas, you were saying something?
Yes, actually, I missed yesterday's class. So can I have the recording of yesterday's class to understand better?
Sure. 1 second, I'll just drop this link in the chat box, guys. You can get the. So this is the recording for the session which I took. So we took a brief intro on what the entire course is about. I've dropped that in the chat box, guys. Okay, you can go through that recording. Okay. So if you have any questions also, again, for any class timing information or for any course price information, please contact your respective institutes. I'm taking the class from multiple institutes at the same time. So please contact your respective institutes for your course time, class timing and pricing. But any question regarding cybersecurity, you can ask me in the next class. And once you have registered, I'll be sharing my phone number as well. If you have any queries, you can ask me on my phone number as well. For the demo, which I took yesterday, this is the recording which I've shared in the group chat. Okay. So you can access the recording from there. And I have explained what the course is about. I've explained what all topics I'll be covering throughout the course, what tools we'll be working on throughout the course. I've explained everything in that demo. Okay. So you can go through that, guys. Okay. I hope everyone has copied that link or accessed that link. Okay. And yeah, any other questions or doubts before we exit today?
Yeah, so today is my first class actually. So we how many classes has done till now?
As mentioned, this is the first class for the course, so you have not missed anything. What I took yesterday
Okay,
was just a simple demo elaborating the entire course content. Okay, so you didn't miss
okay,
out any session. Okay, what you missed out was a demo class explaining what topics will be covered throughout the entire course. Okay, and I've dropped that link in the chat box. So don't worry, you have not missed out any classes until now. This is the first class today.
okay. Thank you.
Okay, right.
Yes. So
So
everyday class will be at 6 o'clock. Sorry for the interruption.
yeah, currently it's 6. Again, from next week we might shift this batch to 7 p.m. 1 hour later.
Okay, okay,
So yeah, 6 or 7. That's it. Not no more alternating than that.
okay. So thank you.
Yeah. Okay. So yeah, that's that. Any other questions or doubts before we exit the class today?
No, thank you for the session, sir.
Thank you, guys.
Yeah,
Thanks for showing
thank
your
you.
interest,
Thanks
and
a
again,
lot.
you're a great bunch. Okay. So yeah, please do join the session tomorrow without fail. We'll be discussing a lot more important tomorrow. Okay. Bye bye. Have a good day. See you tomorrow. Okay. Take care, guys. Bye.